This is the reteaching video for questions number 5 and 6 on the stretching and shrinking unit test, which covers the topic of determining similarity. The first thing that we need to remember is that in order for two things or two shapes or multiple shapes to be similar, the following things must be true. Number 1, all corresponding angles must be congruent. And the second criteria can be said in two different ways. I can either say, 1, that all corresponding sides have the same scale factor, or I could say that the ratios of corresponding sides within a shape is the same. So the first thing that we need to know is if we don't have information about sides and angles, there's no way we can determine similarity. If it tells us that we're dealing with a rectangle, we have information about angles because we know that all rectangles have 90-degree angles. However, if we're dealing with shapes such as trapezoids or parallelograms or anything that doesn't have something about its angles in its definition, then we need to have information about angles. So even if it gave you a picture with side lengths that seemed to work out perfect, but it didn't tell you anything about the angles, you can't definitively say if they're similar. So let's investigate these two methods very quickly. Let's look at scale factors first. I'll use triangles for my example. Let's say we had a triangle side lengths of 3, 4, and 5, and another triangle with side lengths of 9, 12, and 15. I need to determine if these are similar. The first thing I would want to do is match up my corresponding sides. 3 and 9 are both the shortest side lengths, so they match up. 4 and 12 are the middle side lengths, so they match up. 5 and 15 are the longest side lengths, so they're going to match up. Now I find my scale factor. Remember, in order to find scale factor, we take the number the arrow points at divided by where it starts. So in this case, I'm doing 9 divided by 3, which I know is 3. 12 divided by 4 is 3. 15 divided by 5 is 3. So right now, I want to say that they're similar, but again, I can't because I don't know anything about the angles. So in order to determine if this is similar, I would need to be given some more information. So if I knew that both of these were right angles, that's good information. And let's say I knew that this one was, this angle was 30 degrees and this angle was 60 degrees. This would give me enough information because in each of these triangles, I'm given two angles. If I'm given two angles in a triangle, I can find the other. 90 plus 60 is going to give me 150, and I need 30 degrees more to get to 180. 90 and 30 is 120, and I know I need 60 more to get to 180. So now I have corresponding angles are congruent. Corresponding sides all have the scale factor of 3, so these two triangles would in fact be similar. It is important to note that I could have drawn my arrows the opposite way, and in which case if I went from 9 to 3, my scale factor would simply have been 1/3. Let's see the ratio method very quickly and how this would work. If I use the same triangle, I need to compare 3 different ratios. I'm going to compare the ratio of short to middle sides, short to long sides, and middle to long sides. So in this first one, I have 3/4 is my short to middle. My short to long is 3/5, and my middle to long is 4/5. Now it's probably going to be easiest to convert these to decimals, even though these are going to be nice fractions that are going to work out for me. I know that 3/4 is 0.75, and 3/6 is 0.6, or I'm sorry, 3/5 is 0.6, and 4/5 is 0.8. That's just going to help me compare when I get some other fractions. Let's do the same thing for the larger triangle. My short to middle is 9/12, which I know simplifies if I divide both by 3. 3/4, which is 0.75. My short to long is 9 to 15. Again, I can divide both of them by a common factor of 3. 9 divided by 3 is 3. 15 divided by 3 is 5. 3/5 is 0.6. And my middle to long is 12 to 15. Again, common factor of 3. 12 divided by 3 is 4. 15 divided by 3 is 5. 4/5 is 0.8. Notice now that each of these ratios is the same. 8/10 equals 8/10, 6/10 equals 6/10, 75 hundredths equals 75 hundredths. And I still have the information about the angles, so I would say that these are in fact similar. Please make sure that as you approach these problems, you read the directions carefully. If the directions asks for a ratio answer, you need to provide something like our second example here. If it asks for a scale factor proof, you would provide something like the top diagram. If it says choose either, then obviously you may choose either. But remember, you need information about sides and about angles in order to determine similarity.